students, welcome to the fourth session of number system of class 9. On number system, today we are going to discuss representing real numbers on the number line. In the previous section, you have already learned the representation of real numbers on a number line. The real numbers can be expressed in the form of decimal expansion. This decimal expansion helps us to represent the number line on the number line. So, now we take one example. Locate 2.665 on the number line by using successive magnification. You write 2.661. You can observe this one. This 2.665 is greater than 2. That's why it can be written as 2.665 is greater than 2 and less than 3. So, first, how to make this 2.665 on the number line? First, we draw a number line in between 2 and 3. This line can be divided into 10 equal parts. The middlemost part is exactly the 2.5. So next you write 2.6, 2.7, 2.8, 2.9, 3. So now our exact portion is what? The next portion is what? 2.66. This 2.66 is greater than 2.6 and less than 2.7. That's why now you can imagine to magnify this portion. So you can write 2.6 in left side and 2.7 in right side, and you can divide this again into 10 equal parts. The middlemost part is what? You can see this is 2.6. 2.61, 2.62, 2.63, 2.64, 2.65, 2.66, 2.67, 68, 69, 2.7. So, our next portion is what? Now, we exactly represent 2.665. Observe this one. This 2.665 comes in between 2.66 and 2.67 because this 2.665 is greater than 2.66 and less than 2.7. Now you can imagine to magnify this portion. That's why you write 2.66 in left side and 2.67 in right side. Exactly you can divide once again into 10 equal parts. The middlemost part is what? 2.665. This is what our exact point. This is the representation of 2.665 on the number line. So, today I will give some homework. Take down the homework. Homework is exercise 1.4 of page number 18. You can work out these exercise problems. Now, we are going to the next part. The next part is operations on real numbers. So before going to this operations, now we can recall what are rational numbers and irrational numbers. Look at these examples. These are all rational numbers. Here these are all irrational numbers. The rational numbers means it can be expressed in the form of P by Q, where Q is not equal to 0. So, these type of numbers are called as rational numbers. Here, root 2, root 3, pi. The pi value is 3.1415. These numbers are non-terminating, non-recurring decimals. That's why these type of numbers are called as irrational numbers. These rational numbers and irrational numbers together we called as a real numbers. So, now we are going to the operations. The fundamental operations of mathematics are addition, subtraction, multiplication and division. Now take one example. Here 0.24 plus 0.60, that is equal to 0.84. It can be written as 84 by 100. That's why it is in the form form of p by q. That means addition of two rational number is a rational number. Here the second example, root 9 by root 4 plus root 4 by root 16, that is root 9 is 3, root 4 is 2, root 4 is 2, root 16 is 4. Add these two, take the LCM, LCM is 4 and add this one, we get 8 by 4. This 8 by 4 is also in the form of p by q. By seeing these two examples, we can conclude the addition of any two rational number is a rational number. This is one property. Coming to this example, here we add two irrational numbers, root 3 plus minus root 3. Root 3 minus root 3 equal to what? 0. So 0 can be written in the form of 0 by 1. It can be written as p by q. That means any two irrational number is a rational number. Take down another example, 5 root 2 plus 2 root 2, that is equal to what? 7 root 2. The value of root 2 is what? 1.4142 etc. You multiply by 7, we get 9.87. Look at this one. 9.87 is a non-terminating, non-recurring decimal. That's why any two irrational, if we add any two irrational number, either it is a rational or it is a irrational. So this is what the second property. You can look at this one. When we add two irrational numbers, the result may be a rational number or an irrational number. Coming to the third example, here we add 4 plus root 2. 4 is rational number, root 2 is irrational number. The value of root 2 is what? 1.414 etc. So you can add 4 plus 1.414, we get 5.414. So if you add rational plus irrational, then we get what? Irrational. You can observe this property. The sum or difference of a rational number and an irrational number is an irrational. Now coming to the third property, if we add, subtract, multiply or divide two irrational numbers, the result may be a rational or irrational. Pause. Now take down one example. Here you can add 2 root 2 plus 5 root 3 plus root 2 minus 3 root 3. Look at these two terms. Add these binomial terms. Observe this one. You can take like terms one side. Observe this one, 2 root 2 root 2. So these two are like terms, write one side. 2 root 2 plus root 2. Similarly, 5 root 3 minus 3 root 3. So these two are like terms. So separately you can write in bracket. So now add these two like terms. So you know that this is irrational number, the coefficient is 2. Irrational number coefficient is what? Here there is no number, the 1 is present. That's why you can add the coefficients. 2 plus 1 is 3 root 2. Now coming to this one, here the coefficient is 5, here 3. So here is what? Root 3. So these two are like terms. So that's why 5 minus 3 is 2 root 3. This is what our answer. Coming to the next problem, multiply. Multiply 6 root 5 by 2 root 5. So multiply 6 root 5 into 2 root 5. So you take the coefficients one side, 6 into 2 and root 5 into root 5. 6 into 2 is 12, root 5 into root 5 is 5, 12 into 5 is 60. So why it is root 5 into root 5? So it is a square number. Root 5 into root 5 is root 25. Root 25 value is what? 5. That's why root 5 into root 5 is 5. 5 into 12 is 60. Now take down an exercise problem. Now take down the homework, that is simplify the following. 3 root 5 plus root 2 plus root 2 minus 3 root 5. The second example is 3 root 7 into 5 root 7.